All right, so this lecture is just going to kind of help you with section 2.5 or the idea of a proof. So I'm going to start with an algebraic proof. And what is a proof, first of all? A proof is where you justify and argue every step of your math problem to prove that your math problem is true. Basically, you're going to have a two-column proof. On the left side of it, you're going to have the math. On the right side, you're going to have the property or the rule or the logic of why you could go from one step to the next. So the definition of a proof according to your book is it's an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. An important part of writing a proof is giving justifications to show every single step. So here's a list of properties of equality, and these properties we use to solve equations all the time. So the first one, addition property of equality. If you know A equals B, then if you add the same number to both sides, then you know that it has to stay the same. So for example, if you have the number 2 equal to the number 2. If you add 3 to both sides, you're just going to get 5 on both sides. So it kind of seems silly, but you can also think of it in terms of line segments and other things. So it does work, the addition property. You can add the same thing on both sides. Same idea with subtraction, multiplication, and division. Reflexive property tells you, well, A equals B. So if I have the number 2, it's equal to the number 2. Seems silly, but it actually is needed. The symmetric property, if A equals B, then you know B has to equal A. So they kind of go back and forth. The transitive property tells you if A equals B and B equals C, well then A also has to equal C. Substitution property tells you, well, if A equals B and B can be substituted in for A. So if A equals B, we use this a lot too. So if I said A equals 2, anytime you see A, you substitute it in. Or you can take any A and put B in its place, kind of thing. Okay, so those are like our properties that we're going to use for this first example that I have. Okay, so if I saw this over here, and I'm not going through the PowerPoint large because I don't want to do every slide. So I just liked it. They had some great examples in here. So if we look at this problem, if we're given the problem 4m minus 8 equals negative 12, and we're going to write a justification for each step. Well, if we look at the first part, it's just given. That was what we were given to us. And then the first step that we would do is add the 8 to both sides. And when we do that, we're adding the same number, we're adding the same number to both sides of the equation, and we called that the addition property of equality. So that's how we're justifying this next step. Now, how do we go from the 4m minus 8 equals negative 12 to 4m equals negative 4? Well, we added 8 to both sides, but then we simplified after we added that 8. And that's how we justify that next step. We simplified to get there. The next thing that we would do is divide by 4 to solve, and that was our division property of equality. If you divide both sides by the same thing, you're going to have the same thing, and then you simplify. So basically all the blue on the right hand side, these steps are what you're going to list on a lot of the two-column proofs that you're looking at. It depends on the textbook you have, but we're going to relate this a little bit to looking at a geometry. So here is we want to look at the justification again for each step. I know the answers are on here, but it's easier than me to type it. Maybe I'll do this. There we go. And then I can click to get the next step there. That's perfect. Okay, so if we're looking at this line segment, look, it's the same length as N and O, and we're going to justify some different things. So first thing is if we look, NO is equal to NM plus MO. So we're kind of saying, well, if they're equal in the big length, right, then if we break it up, they're still going to be the same length. So this one's segment addition. And we have the segment, and in your book you have a list of properties that apply, the same equality properties apply, but we call them with the segment basically. So the next thing would be, okay, so we know NO is equal to this. So where did we go to these numbers and letters, these X's in here? Well, what we did was we used substitution to substitute. Well, we know 4x minus 4 is the whole length, and we know that 2x is this chunk here, and then 3x minus 9 is this chunk. So we can go here with that next step, and then we're going to simplify both sides. So notice there's no number in front of this parenthesis here, so this parenthesis really isn't needed. So that's where they went 2x plus the 3x to get 5x. And then they're going to start doing the steps to solve this equation. They took this 4x, I wish I could write on this, but it will not let me, and they subtracted it over to 5x to get 1x. And they called that the subtraction property, which we just looked at on the other problem. And then how did they get to the last step? Well, then they added 9 to both sides to get here, and they called that the addition property. Okay, so that's kind of walking through one that it looks more like geometry. It's still a lot of equation working and things like that. And I can't remember if okay, so you're going to justify each step for an angle. So I kind of liked this one too, and this is probably the last one I'm going to walk through. So this one says justify each step of your formula again, and we're looking at some different angles. So it says the measure, that's what the M stands for, of angle ABC, so that's the big one, is equal to the two chunks, right? ABD, and adding angle DBC. And when they say measure, they're saying the measure of each one is equal. Okay? Where do they get this one? Again, you have a list in your book of the different properties, and but this one's the addition, angle addition postulate is what they call this one. I would actually probably print off all of the little lists of different ones, and I could show you where that is real quick in a sec. Okay, so then where are we going to go from knowing that the whole thing is equal to the two parts? Well, we're going to substitute in again, and that's just substituting in the blue for the chunk of the blue one, the green, and then they have over here the whole thing is equal to 8x, and then I can solve, showing each property as I solve again. Okay, so you can start with it and kind of work your way down. Again, right on the left hand side your steps, left hand side your steps, and the right hand side will always be every single justification. Now I'm going to exit out of this real quick, and I want to show you, hopefully I'm still in it. I'm not, I'm in YouTube. That's right, my age. I'm going to show you what you really want to have available. If you do not have the online textbook, that's fine. You're going to have this in your pages in your textbook. And this chapter on chapter 2 on the proofs and the logic can be very challenging. Make sure you do each section until you understand it. So this is 2.5. And here is that exact thing that I showed you, and I would print that page off and have it with you so you can remember each name for each step. And then they have another one right here. These are the properties of congruence. So they're the same idea of the properties. The names are similar, but you can show it with angles and different things. Notice the symbol is got a little line over the equal sign. That's because we're talking measures are equal. That's the congruent sign. So just note that you can't use an equal sign when we talk about the measure of things. We use a congruent sign because they're not equal. They're two different things. They're just equal in measure. So here are some of your problems. You're going to do some just like we did. You're going to walk through every single step that you did. So you do the problem, walk through step. On the right hand side or left hand side you show the problem, the right hand side you show your steps or your properties. And same with down here, you can see these are very similar to the one I gave as well. And then it goes into some with the angles, okay, where you just justify each step and go through all of those different things. So anyway, so that's kind of the idea of a proof. And in section 2.5, biggest thing is to make a list of all the different rules so you know what they are to go from one step to the next.